Welcome everyone to Care Path. Today we are going to discuss about number system. This topic is very important in computer science and electronics as it plays a huge role while building algorithms or logics in programming. And we are going to discuss these algorithms like conversion from one base form to another base form. Coming to the base form, what I mean is x z. It represents the base z and x is the value of that base. We also call base as radix. The first example being binary numbers. And as you can see in binary number, we have 1, 0, 1 and 2, which consists of 0 and 1. So this base also represents the number of digits which will be used to produce a value x here, which is 101. Similarly, we have decimal number and octal number and hexadecimal number. All of these have different bases. That's why we have different names and different values that we are using here. In decimal, we use 0 to 9, and in octal, there is 0 to 7, and in hexadecimal, we use 0 to 9 and 10 to 15. But we use alphabet from A to F to represent 10 to 15. If we use 10, 15, it will create a confusion whether it's a 10, 15, or it's a 10 or 15. So, and we are going to purely discuss only the whole number of integers in this video part. And this will be, and this video, and this will be discussed in the next video. And all the similar topics are grouped together in the same video. You will find if any algorithm is same, it will be covered in the same video. And for this whole integer part, the algorithm is similar. So we're covering this in this video. And for this non-integer, we will be covering this in the next video because the method is a little bit different for this. So it will be easy to remember for you guys. And we will be discussing from binary number. Conversion from decimal to binary, decimal to octal, decimal to hexa. This will be covered in this video. And the method is similar for every conversion. First, there are two methods for converting from decimal to binary. First one is basic method, which will be very useful for memorizing the binary numbers. Don't have to by heart it like 1101, what is the number of decimal, or you have to convert from reverse like 124, what will the binary number. So by using this manual method, you will be able to get a reference like from where the next number will start. So coming to the method, we have 0 and it will be represented in 2 bits, 0 and 0. And next is 1 and 0 and 1. If we observe, we have changed one bit here from 0 to 1. And I have mentioned here the manual method, which is a combination of 0 and 1 in the increasing order. So if we are starting from 0, we have to take the next combination of 0 and 1 from there. If we are starting from 4, then we have to take order from 4, increasing order from 4. So next will be 2. And if you observe again, here we have 1, 0. Because after 0, 1, the only combination that will be matched in the increasing order is 1, 0. Next is 3, 1, 1. And similarly, we can take 4 and you can represent this with 1, 0, 0. Because the combinations have been ended for the 2 bits. We are starting from 3 bits here again. 1, 1 has ended, then there are no combination for 2 bits. Next it comes 3 bits. This is 1, 0, 0. Then similarly for 5 in the increasing order 1, 0, 1. And similarly to take further, we have 6 represented 1, 1, 0. We have 7 represented as 1, 1, and 1. If you multiply these numbers, like I have given in the right side here, like how these numbers have been multiplied. If you observe, this is a 0. This we have to count the bits from right side to left, and this is a 0, and this is the 0th bit, and this is the first bit, and this will be 0 bit here, this will be first bit here, and this will be second bit here for 4. So we take the second bit number, which is 1, and 2 to the power, because the base is 2 here, we will be taking 2 to the power the position of the bit, which is 2. Then we will be multiplying with 0 into position of the bit, 2 to the power 1. Then again 0 into position of the bit, which is 0. We'll be getting 4 after adding this. Similarly, if you want to test any number, you can just write down on your paper or in your notebook, wherever it can be possible, in or in laptop. You can just write in a similar manner. You can just go in the order 100, 101, 110, 111, and the next will be 100, 1001. You can practice a lot, and you don't have to remember these how we can convert from decimal to binary to by heart these things hardly. This method is very useful when coming to referencing what could be the next number binary. You can have this manual method will be very helpful in that case.